Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. So for the next chapter 3, correlation and regression. For the learning outcome, at the end of this chapter, student will be able to calculate the correlation coefficient by using Pearson's method. Second, determine the simple linear regression equation. And third, estimate the value of y and x is already known. Next content, we have introduction, scatter plot, correlation, simple linear regression, and last coefficient of determination. First, we go to the introduction. A researcher sometimes wants to study the relationship between the variables. For example, relationship between the concentration of an injected drug and heart rate. And next, the consumption level of some nutrient and weight gain. Okay, for the purpose of this chapter, are two or more variables related? If so, what is the strength of the relationship? What type of relationship exists? What kind of prediction can be made from the relationship? So regression and correlation analysis is used to describe the nature and strength of the relationship between two continuous variables. So independent variable known as x, which is variable that can be manipulated, influence the other variable. For dependent variable y, cannot be manipulated, create response by the independent variable. Correlation used to determine whether a relationship between variables exists. Regression used to describe the nature of the relationship between variables. A visual way to describe the nature of relationships between independent and dependent variables is through scatter plot. It is shown by the pattern of the plot. A scatter diagram will give a view of either linear, positive or negative, or nonlinear relationship. So we look at the scatter plot diagram. We have 6 types, which are strong positive correlation, moderate positive correlation, no correlation. This is no correlation. This is moderate negative, strong negative correlation, curvilinear relationship. Okay. Correlation. Correlation coefficient denoted by R, used to determine the strength of the relationships between two variables. Range of correlation coefficient is from -1 to 1. Okay. So R equals to +1 or -1. Perfect positive. This is perfect positive. Perfect positive. -1 is perfect negative. Okay, perfect negative between relationship between x and y. So 0.8 to 1 or -1 less than r less than -1 0.8 is strong positive. This is strong positive, strong positive. This is strong negative. 0.5 less than equals to R less than 0.8, or negative 0.8 less than R less than negative 0.5, fairly strong positive or negative linear correlation. Next, 0 less than equals to R less than 0.5, or negative 0.5 less than R less than 0, very weak positive or weak negative linear correlation. If R equals to 0, no correlation or relationship between X and Y. Pearson's product moment correlation coefficient denoted by R. So R equals to summation of xy minus summation of x times summation of y over n over square root summation of x square minus summation of x square over n times summation of y square minus summation of y square over n. And we simplify this formula, we got this. So R equals to n summation xy minus summation x times summation y over square root n summation x square minus summation x square times n summation y square minus summation y square. Okay, remember, you must remember this formula. We go to the example 1. Compute the value of correlation coefficient for the data obtained in the study of the number of absent and the final grade of the 7 students in the statistics class. We have the data here, and we assign number of absent as X and final grade as Y. Okay, we remember the formula for R equals to n summation of X, Y minus summation of X, summation of Y over square root n summation of X square minus summation of X square times n summation of Y square minus summation of Y square. Okay, so from the data we total up the X, we got 57, and Y we got 511, and the value for xy we multiply 6 and 82, 2 times 86, 15 times 43, and we total up, we got 3745, and the value of x square here and y square here. X square, 6 square, 2 square, 15 square, and the summation of x square we have 5, 7, 9, and summation of y square we got 3, 8, 6, 6, 3. So from the information below, substitute the value to the formula of R. So n equals to 7, summation of xy, we got 3, 7, 4, 5, and minus summation of x, we have 57, summation of y 5, 511 over square root n equals to 7, summation of x square. Summation of x square, we have 579 minus summation of x, we got 57 square, so and times with 7, summation of y square, we have 38663 minus summation of y, we got 511 square. And press the calculator. From this value, we have the answer of negative 0.9442. So the conclusion is strong negative, because the value we got negative number, negative value. Okay, we got this formula, and there is strong negative relationship between a student's final grade and the number of absent of a student. That is, the more absence a student has, the lower is his or her final grade, which means more absent, the student have lower final grade. Okay.